let's go through LeetCode 459, repeated substring pattern. For this question, it gives us a string S. Check if it can be constructed by taking a substring of it and appending multiple copies of the substring together. So, for example, the first example, right? A, B, right? So we know we can append AB twice. So this return true. And ABA, we cannot find any repeating pattern, right? But ABC, 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 right? So we have ABC append multiple times. So for this question, what we think about is that we can also use something called ZL algorithm. So for this string, right, S, we are going to create a Z array. So what does Z array mean is that from this index I, what is the length it can match from the start of the S, right? So, so for example, we have A, B, C, A, B, C, right? And A, B, C, right? So let's set the index 0 to be 0, the Z0 to be 0. This depends on what way we define this ZI, right? So we know this matches the whole length. So you can set this one as the length as well if based on whatever you need. And B does not equal to A, so this matches 0, right? C does not equal to 0, right? And this A, right, equals to this, right? So we'll see this equals this, right? So actually from this one, from here, from this index I here, right, we'll match length 3, right? So this is, right? So we'll have 3, right? And this B does not equal to A, right? So C does not equal to A, right? And this A will match length 3, right? So you will have create a Z array like this, right? So we say for Z algorithm, the advantage is that if we have this kind of we already match here, right? We know this A, B, C. We have this matches the start, right? So we call this a Z box, right? So the advantage of Z box is that inside the Z box, when I iterate, we can match its length at most to the edge of the right bound of the Z box, right? So if for example we have this B, right? We know this is ZI is 0, right? So this should be also be 0, right? Because we already calculated in the previous one. So but for example, if we have something which match to the match to the end, right? We need to try to check whether the character after this they are equal, right, or not. So that is a basic concept of the algorithm, is that for any characters inside of the Z box, we can skip the matching for this, right? The matching for this part. In the when match outside of the Z box, we still do the brute force trying to calculate. But if we skipping this part, the time complexity will be linear. So that is the concept of the Z box. So for this question, we write create a Z array, right? And when we calculate this I, right? So for example, this is 0, 1, 2, this is 3, right? So if we have this number n can divide is divisible by this I, right? That means it is multiple times of this part. And also we have this zi plus I equals to n, right? Then we return true. Otherwise we return false. So let's begin to write code for this, right? We'll have a character array equals S2 array. And we're going to have int n equals array dot length. And we'll maintain that the box left bound to be 0 and the right bound equals to 0, right? And we're going to create a z array equals new int n. So what we do is that for int I equals to 1, I smaller than n, I plus plus. Let's say zi, right, equals, we can also write if I smaller equal to r, right? We can also just make sure this is not smaller than 0 to be here, right? Max.max 0, and we have max.min. Z I minus L, and right minus I plus 1, right? So this is part we can save us the calculations. That means our Z box, right? So the part, for example, we maintain a Z box here. So the part inside this kind of Z box, right? So we can calculate this part to the edge of the right bound of the Z box. So if I is outbound of the Z box, or the right or we'll say we extend this ZI to original Z box right bound, right? So what we do is that we can write this while we try. This is just proof of I plus the I smaller than n, and in the array zi equals array I plus z I. Right? So we for any of this we need to compare one by one. We have I L equals I, right, equals I plus z I, and we are going to extend z I by 1, right? So what we can sorry, this should be inside for loop. And when if we have something like for the z array, right? If we have I multiplied by I equals to 0, and I plus z I equals n, right? Then we return true. And then in the end, if we don't have such segment, we just return false. Okay. Change this code to Python, should be similar. We're going to have, for example, array. We'll have length equals n equals length s, right? And we're going to have left, n, left, right. We are going to maintain this left and right to maintain the z box left and right edge, and we'll have z equals 0 multiplied by n, right? So what we do is that for I in range from 1, right? 1 to n. So I say zi equals max. At least it will not. We cannot set the length smaller than 0, right? So mean is the I minus the R, right? So we know any Z box, right? So for any I inside of the Z box, we can find the corresponding part in at the beginning. So but the thing is that we cannot exceed this Z box, so that we'll have the length will be right minus I plus 1, right? And if outside of the Z box, or we just have this ZI, right? Just to the right point, or we have a new, in any case, we have the new match. So what we do is that we have while should be here, right? So should be here, right? So we'll say while I plus Z I smaller than n, and s, right? S Z I equals S I plus Z I. In this case, we'll have left equals to I, right equals to I plus Z I plus Z I. And also we need to extend Z I plus equal to 1, right? So when we calculate this zi, we say if we have a mod by I equals to 0 and I plus the I equals to n, right? Then we return true. Otherwise, cannot find, just a return false. So should be return false.